Hello, welcome to the utility sales training for the Part 2 for Management Requirements. I'm Frederick Cade and I'm the Air Force Utility Reimbursements Program Manager working at AFCEC Energy Rates and Renewables Division.
And I'm Jim Snook. I provide support to Fred Cade, and from 1992 through 2010 I worked at AFCEC on the Utility Rates Management team. From 1995 through 2010 I was the manager for the Utility Reimbursement Program. This is part 2 of the 3-part series. This part is management requirements. It's specifically for the flight chiefs within civil engineering, flight chiefs in operations, installation management, and engineering. Part 1 is for the base civil engineer and other civil engineering leadership. Part 3 is for the utility engineer. These 3 parts are independent of each other. You can watch Part 2 without having watched Part 1, and you can watch Part 3 without having watched Part 1 or 2. We're talking about utility sales. And sometimes we call utility sales utility reimbursement. Sometimes we call it utility resales. It's all the same thing. What we're going to do today is explain why it's important to you and what is needed for the utility engineer to maintain an efficient utility sales process within the civil engineering squadron, and why accurate cost information is so important to this program. Here's an overview of today's presentation, and what we're going to talk about is what utility sales are, why those utility sales are important to the civil engineering squadron, and why support is needed for the engineer to calculate the sales rates and operate a utility sales program that will provide maximum revenue to the civil engineering squadron. On an Air Force base, everyone is provided utility service by the civil engineering squadron. Within these, all the customers, there are 2 categories of subcategories of customers. There's non-reimbursable customers. Non-reimbursable customers are those that do not pay for their service. Their utilities are funded with appropriated funds. There's no reimbursement required. And the second category of customers are reimbursable customers. Those folks are required to pay for utility service. Let me say a few words about the authority to provide utility service and collect for it. All right. 10 U.S.C. 2494 specifically provides authority for the use of appropriated funds to provide utility service to MWR. A cautionary note is found at 10 U.S.C. 2491, which specifically limits the use of appropriated funds to operate and maintain a golf course in the continental United States. Specifically, you're not allowed to use appropriated funds to pay for utility service for a golf course in the continental United States unless it's located at a remote and isolated location. The other authority that we'll touch on briefly is 2686. That provides authority for the civil engineer to provide utility service and collect for that service to a customer on an Air Force base or near an Air Force base if it's not otherwise available from another source. All right? That statute specifically says that the proceeds from that sale goes into the O&M account. Goes back to the appropriation that's used to fund utility service, which means those money goes back to the O&M account. The other authority we'll talk about is 10 U.S.C. 2872A, which is the authority for the base civil engineer to sell utility service to a privatized housing complex. That statute is a little bit different than 2686 in 2 ways. 1, housing can be sold utility service even if it's available from a local utility. The other difference is the housing statute provides for the additional other services to be provided, such as pest control, snow and ice removal, telecommunications, firefighting, and police service. Those utilities are not covered by 2686. For the 5 basic categories of customers located on the installation, each category of customer requires a unique sales rate to be calculated. Some of the comments I'll give you on this: the DoD rate also applies to medical support facilities. And I will say this, we're back to words again. When I say sales rate, I could call that a utility rate, or I could call that a resales rate, but it's all the same thing. It's the rate charged for the provision of utility service. Here you can see the annual approximate Air Force budget for utility service. It's usually about $1 billion. Of that $1 billion, $200 million, 20% of that $1 billion, comes from utility reimbursements. The point here is the utility sales program provides a significant amount of revenue for the civil engineering community within the Air Force. Here you can see the total O&M budget, or about $35 billion for the Air Force over a whole year. The green segments at the bottoms of the bar indicate the sales revenue. Those are the dollars that come from utility sales customers. The blue segments in the bar are the utility payments that are made from the appropriated fund account. That's coming from the O&M account. Red section at the top of the bar is the remainder of the annual O&M budget. Starting at the left, you can see that as we currently do it, the utility sales revenue is approximately $200 million a year. If we don't identify all the customers and don't collect those money, you can see that we collect less than $200 million, and the red dot, the red square at the top of that second bar indicates money that's paid from appropriated funds for the utility costs of these reimbursable customers. The third bar, the all reimbursables identified, shows what happens if all the utility customers are identified, collections are every bit as due, and it actually frees up some money into the O&M account. That is the green bar at the top. So the bottom line here is, if we don't collect from these customers, their utility bill is paid with O&M funds that could be used for other things. This describes the general steps in collecting for utility service. And these steps are true for a utility company or an Air Force installation. The customers are already connected to the base utility system, and they're going to receive service regardless of the payment process. You can see that since the service is provided, the things that are important here are the rate calculation, the meter reading, and invoicing for an Air Force base. While these are all important steps, the focus of the three-part series is on creating the utility sales rate. So some variation of this method you see is used by every utility company in the United States. For a period of 1 year, they determine the total amount of revenue they will require in order to run the company. For the same period of year, they will determine, or they will either estimate or look at records to see how much service will be provided. In the example of electricity, it'd be kilowatt hours. In the example of natural gas, it'd be in million BTUs. Water could be in thousands of gallons or thousands of cubic feet. They then calculate a utility rate by dividing the dollars required by the quantity to be provided. Now, this is a very oversimplified statement of how it actually works. If you would look at a rate filing for a large utility company, there's enough paper generated to fill a boxcar. It's a lot more complex than this, but every utility company uses some variation of this method. This method is what's used at the Air Force to determine what the utility sales rates are. This particular slide is true for both utility companies and Air Force installations. Sales rates can be calculated with very accurate data, or they can be estimated. And if they're estimated, they're questionable. That is, they're open to dispute by the customers. What you see here are some comments on the economics of utility service. There's two situations you'll see here. The economics for a local utility company are pretty simple. Either they collect enough to pay for providing the service, or they go bankrupt. But the Air Force has got an entirely different situation on base, okay? Let me explain this. The total annual utility funds for the Air Force is equal to the money we collect from utility sales plus appropriated funds. Or you could say it another way, which is the appropriated funds that we use to pay for utility service are equal to our annual utility dollars less the money we collect for utility sales. Here's how we determine what our monthly revenue is for the provision of utility service. We need a sales rate, and that sales rate, as we've discussed previously, is based on a year's cost and usage data. How do we calculate that utility sales rate? Okay? For the Air Force, there's a lot of parts or components that make up the cost of providing utility service and this utility sales rates. So all these components are categorized into either distribution costs or commodity costs. Now, there's a difference in our resales customers. Some of our customers pay for distribution costs, but all of our customers, all of our reimbursable customers, pay for the commodity costs. And what we're getting into now is some of the details that make this complex for the utility engineer. Okay? He's got to have all the details to support his calculations to make all this happen, or he can't collect the revenue that he needs to make this going. Let's talk about utility commodity. When we talk about the utility commodity, we're talking about that unit of measure. We're talking about kilowatt hours for electricity, million of BTUs for natural gas, or thousands of gallons of water. The next slide, we're going to show the Air Force Base water production and distribution system. So what we've got here is an Air Force Base. You can see the Air Force Base has got buildings. It has a water distribution system. There are lines from the water distribution system going to each of the buildings, and you can see two sources of water. You can see the water that's bought on the left there. We've got the commodity is purchased from a city utility, and our second source of water is at the bottom. You can see we've got wells where the base actually pumps water out of the ground into the distribution system. So what we've got there are commodities that are either purchased or produced, and then we've got the water distribution system. And we have costs associated with both the commodity and the distribution system. Okay? On the next slide, we're going to show the basis for some of the commodity and the distribution costs. The commodity, as we've shown on the diagram of the base, the water system, the commodity will be either purchased or base produced. First, if the commodity is purchased from the local utility, that would be like water from the city or electricity from the local electric company. That is one possible source. Now, the second option for purchased utility service involves a situation where a utility privatization contractor has bought the base distribution system, but this contractor is also the provider of the commodity to the local community or the base. The combined service of providing that commodity and the on-base distribution system together is utility service for the purpose of utility sales. The commodity can also be produced by the base. Okay? If the base is producing the commodity, there'll be costs associated with operations of the plant. Let's say it's an electric plant. You'd have labor, materials, whatever to run that plant. You'll also have possibility fuel to generate electricity. If you're treating water or wastewater, there'll be chemicals involved. If you're running a water treatment plant, there'll be other utilities required, such as electricity to run the plant, and there's always capital required to build the plant. Next slide, we're going to talk about distribution. There again, distribution can be either provided by the government or a privatized contractor. Here we talk about the details on the sources of cost for a distribution system. A distribution system can be owned either by the government or a contractor if the system has been privatized. Okay? In the case of a government-owned system, then the distribution costs will be related to the operations and maintenance of the system, projects that are used to keep the system up and running, and the capital required to build the system. In the case of a privatized system where the utility privatization contractor owns those pipes and wires on the base that provide service to the installation, in that case, the base civil engineer still buys the commodity. He will buy that at a master meter or a substation. That commodity is then delivered to the on-base buildings by the UP contractor. But the bottom line is, the base civil engineer is still providing utility service to those buildings. The utility privatization contractor is like a trucker. He is delivering that utility service to the buildings on behalf of the civil engineer. So here's a list of specific cost elements that are used by the base utility engineer to calculate a utility sales rate for each service provided. Services being electricity, water, gas, wastewater treatment. Okay? Can also include steam or chilled water. Depending on the commodity supply contract, the utility engineer will calculate his sales rate for all these customers, at least annually. But if he's on a contract that has a monthly price that varies, he has to recalculate this rate every month. Now, Fred is going to talk about some of the cost data requirements.
All right, on the slide that's up right now, what I'm taking is the data requirements that Jim just talked about and breaking them down into the different categories of customers that you see. So for like military family housing, you have a basic cost, other utility cost, line loss, and connection fees. And this slide just goes and shows what the costs are for the non-federal, the federal, non-DOD, your DOD, and then your MWR rates. Now what I also wanted to break out here is that there are numerous sources of information that are essential to identify the cost incurred to provide utility services. The slide gives an overview of the different sources within a CE squadron that a utility engineer can go to obtain information. While it is ultimately the utility engineer's responsibility to collect the information, providing timely and accurate information is a team effort. And it goes without saying that the better the different sections cooperate with providing accurate information, the more successful the utility engineer will be in calculating the correct utility rates for reimbursable customers, the more reimbursable dollars that the BCE will be able to collect. Now, the sources of what we're talking about now, sources of cost data. So if all the expenses are documented correctly, then the utility engineer would easily pull all expenses from the end of the year BCE cost report because all the expenses were properly documented in IWIMS. Information was properly documented in the correct account codes and all properly documented in the proper customer category codes. But we know that that's not always the case. And since that's not the case, the utility engineer has several ways to collect the data. We've already talked about where to find the data. That's what the last slide was. Now we will briefly discuss how to obtain that data. If the financial management section does not have a complete collection of all the cost from the different sources that we mentioned earlier, then the utility engineer will have to obtain the data from different POCs in the squadron. The utility engineer should go to an engineer or programmer and ask him or her to export all the project data in ACES. Now what you're going to get with that is that the project manager is going to come back and say, you want all of it? And the utility engineer is going to have to say, yes, I want all of it. Because the reason for this is that a lot of times the project engineers will overlook a specific type of project that a utility that has utility expenses in it. So if the utility manager pulls the full list, which is probably about 5,000 to 6,000 entries, he or she can easily pull out the utility projects in there, and we make sure that we don't miss those. And we'll cover the service contracts in the following slide and labor cost data in a subsequent slide during this presentation. Now the utility engineer can go to the environmental section of the squadron to ask for a list of projects in which permits were generated. Like the ACES data pool, the utility manager can review that list to see where the utility work comes from for environmental permits. Service contracts and Sabre IDIQ contracts are broken out here to explain the need for this information. A lot of times people want to know why the utility engineer should request this data. Well, have you ever seen a utility patch or a pavement patch where they have repaired a utility line in the road? A lot of times that work was done on an IDIQ delivery order. Or maybe you have a new water line that was installed and you have to use a Sabre contract to do the work because it wasn't quite large enough to be executed as a project, but it was too large to be completed by the in-house personnel. We see a lot of the service contract data where contractors will come in periodically, whether it be monthly, quarterly, or yearly, and they'll recalibrate meters, service the lift stations, perform pressure testing on gas lines, or other service-related activities. So it is important for the utility engineer to find out what type of service contracts are performed on the base to get this relevant utility data. Now, for the slide, first the utility engineer should check with the ops flight to find out if the service contract data is entered in IWIMS. And if not, he or she should go to the financial management section and ask for a list of all delivery orders. The utility engineer should be able to get a list of all the delivery orders from there, and by doing that, the engineer will be able to pull out more of the utility expenses in service contracts and IDIQ contracts. As you know, it takes personnel to operate the utility plants. Some, like steam plants, are fully manned and operated. Others, such as water treatment facilities, may have personnel who only operationally maintain the plant, or in this case, treat the water periodically. For those periodically operated plants, we get into a situation in which we must determine the full-time equivalent workload. As we have already noted, the cost to produce a utility is separate from the cost to distribute and deliver the utility. Labor cost data is part of the expense to produce the utility, and it's spread across all the customers. So it is important that the utility engineer obtain the correct data to be used in determining the utility sales rates. For bullet 3, it says if the shops do not enter the cost into IWIMS, then the cost comes from civil service payroll or from support contracts. So the utility engineer should go to the financial management section to get this information. If the labor costs are not tracked separately and they have to estimate the full-time equivalents, then the utility engineer should go to the ops flight to get this information. Now we need to talk about the sources of data that we can pull from IWIMS. Shops have a tendency to enter their work into account codes that they have historically used in the past. A lot of bases do not understand what the account codes mean and how they impact cost and budgets. For example, we have found that many exterior electric shops will enter all their work into the account code 53015, which is the electrical distribution account code. Within that account code, there is a cost for, say, Christmas tree lighting, replacing the lights on a ball field, changing bay lights in aircraft hangars. It's any high-reach work that the exterior electric shop will normally do. So knowing that it's important to understand the summary total for the account code 53015 and the BCE end-of-year cost report, you have to understand that they may not contain work exclusively just for electrical distribution, because the examples I just gave you for like Christmas tree lighting or replacing light bulbs on the ball field aren't exactly straight electrical distribution work. So if that's included in that account code, then that account code does not have all the accurate data that we need for it to have. So the only way to really find out what is included in the account code is to periodically check the work order and the IWIMS data to see if the work is being coded correctly. So that's why in the slide we say export the data into Excel. So you can go to the ops flight and get them to export it into Excel so you can see the information in front of you so that you can pull out what needs to be pulled for each of the account codes. It is not the utility manager's responsibility to ensure the work is coded correctly. However, because he or she is the end user, it is their responsibility to ensure that the receipt of accurate utility cost. So working with the ops flight in conjunction with the financial management section will help in obtaining this information. The financial management section also wants to get accurate data because they use the budget codes for the end of year fin plans and for requesting money for the next year. The table at the bottom of this slide shows examples of incorrect account code entries. The first one, we have a hot water leak between buildings, which is said to be water supply and distribution. Hot water is not part of the water supply and distribution account. It may be hot water plant operations, but it's not water supply and distribution. Or we have one that was listed in water supply and distribution as missing a smoke alarm. Again, that may be electrical work, but it is definitely not water supply and distribution. And finally, one of the work order titles that we saw was repair chilled line between at a building. Well, the repair of the chilled water line would be part of a chilled plant code, but it's not part of the water supply and distribution. So these are just examples of the things that you should look for when going through work order data. So our takeaway here is that we want accurate sales rate. We need accurate sales rates to provide revenue to the civil engineer. And from that accurate sales rate requires accurate data from all the utility service cost elements. We also need to make sure that our costs are entered correctly in IWIMS, in ACES, in any of the programs that we use, because accurate sales rates are required for accurate cost data. And if we get the accurate cost data, then we can charge the right utility rates to the right reimbursable customers and ultimately pull back that money that we can use for the O&M account. So this concludes section 2 of our training. If you have any questions, please contact me at the information that's listed on the slide. We have 2 other additional presentations. Part 1, which is the executive overview for civil engineering management, and Part 3, calculating utility sales rates for the utility engineer.